My name is Nick Wiegand. I'm down here in Duluth in the Connect's office. And we're talking a little about the scripting that's available in Intellect and framework software. This first slide is a quick lesson on programming. That's not really what it's going to be. I can't teach you how to program in a half hour or an hour here, but I can show you some of the things to watch out for and kind of give you a taste of what the abilities are in the scripting language here. And I'll preface it by saying I'm not a programmer, and it's not that difficult to do in the scripting, and I think sometimes programmers may do some things and overkill sometimes. But some things I'll cover is the introduction to programming in general, what it is, kind of show you how to write a simple script, maybe show you why or when you would need it, and I'll also point out some methods of debug, using debug statements and troubleshooting your code to figure out is it a syntax error or is it some kind of logical error in the code. And then I'll show some registers, how to get data in and out of them, and how to share it to other products or projects. And then the very last thing I'll do would show a little bit about some scripts that I've written and others in the office have written in the past that kind of do some pretty cool things that maybe you guys can use in your applications, or just to get an idea what the capabilities are and how powerful the scripting can be. So here's a pretty simple application. The customer wants to know what the distance between the two circles are. Well, center to center, that's pretty easy to figure out. A little more challenging to figure out would be what's the distance between edge to edge. So what's this white space? What's the size of that? Now, if it was fixed, okay, you could do that, but if these dots can move all around, or these holes can be anywhere in the field of view, then it becomes a little more challenging to have the tools check and measure that gap. So using several tools, we can find the diameter of each of these circles and find the distance between center to center, and that gives us all the information we possibly need to calculate that middle portion. So here's an example just showing radius 1, radius 2, and then the blue things are blue lines represent data that's being given to us, and then this dotted line is what we're going to calculate. And, it's a very sophisticated mathematics problem. It's distance minus radius. Pretty complex. And the script to do that can be as difficult as this, or we can actually get it down to even one line if you really try. But this is what, once you have a script tool, then this is what the code actually looks like. And I'll go in and I'll type this up while others are all here on the line to show you the steps that are involved to do this. So the scripting language, it's very similar to Java. It uses some of the same techniques as writing code in Java. It has some of the good things of Java and some of the bad things of Java, so it's kind of give and take there. You always want to put comments in your code, just like in Ladder Logic or Visual Basic. The more comments you have, it enables a user or somebody else to come up behind you and check on your code and figure out if something happens in the future or if they need to modify it for some reason. There's some reserved words that have special meaning. So some words such as true or false or pass and fail, those words are reserved, and you can't create a variable with that name. If or while, those are also reserved words. And you always want to end all the lines with a semicolon. And there's asterisk there because all is never all-inclusive. There's always exceptions. And in this case, an exception would be if you have a loop or a conditional loop. Like an if statement doesn't end in a semicolon on that line. But I can go into that and show you how that works. So here's the script soft sensor is located just like any other tool. It's down near the bottom of the list. It's under script. You click on it and click on the field of view someplace, and then the script gets added. Once it gets added, you're presented with a properties window, just like a traditional tool. There's two different kinds of scripts. There's scripts that are down here in the product level, and there's also scripts up here on the system level. The scripts that are in the product level, they can interact with all of these tools, and also be directly a part of the inspection results if it passes or fails. The script up here in the system level, it's called a background script, doesn't have access to each of these tools, or even the script. It only has access to the product, or product information. So if you wanted to have this script kind of monitoring some values, the way to share some of those key values you're interested in is use a register in the script down here, and you can pass variables to the foreground and the background. So that way you can get value from here and ship it over to this product, and this one up here can get both of those pieces. So the script is like a tool. So if you have a blob tool in product 1, you can't really get at that from product 2. That's kind of what I'm trying to get at here. So when you drop the tool in the field of view, you get this property window here. There's only 2 tabs, a general and an outputs tab. You give it a name, and you press the edit button. And when you press the edit button, you're presented with the expression editor or the script editor window. And something about this window here is you have this stuff in the beginning is required and automatically added in. Up here, we'll go to class. That's the name of the script you've created. So if you notice, hit my script when you first create the tool, it'll add it there later. So let's say you take a piece of a script from somebody else, you cut and paste it, and this name is incorrect, then you'll have to either change the script or you can change the name here to match what you currently have. So I can get more into that later. Between these 2 main braces is where most of your code is going to be, and you can, I'll show you in the future, but this is a commented line. We also have some line numbers. Those line numbers will become very important when you're trying to troubleshoot, figure out which line of code is causing your problems, causing an error. And then also on the right, we have this parameters area. These are all soft sensors in this example that I've drawn, and these are things that I have access to. So I can expand a tool and see what's available to me, so I can get data out. So I want to know if this tool is passing or failing. I can get that data, bring it into the script, and then do some kind of logic on that, or calculations on those. Some of the more common functions are right here. So if you want to write to register, you can expand this and see all the different examples, different types of registers you can write or read to. And if you double click on any of those items, in any of these regions, it automatically dumps it into your code, wherever your cursor happens to be at that time. Then there are keywords. There's more things if you're not sure how to declare or construct a while loop or a for or if statement. It'll get you pretty close there. It'll put the code in for you. It'll kind of explain what needs to be where, and then you can go in and edit to your own functions. So when you're done with a couple lines of code, or you're done with the script, you want to press the compile button, which is up here. And that compiles the code and turns into a machine code, so you can use it. And then once you hit the OK button, you're ready to go. If you make some changes in here and you press the cancel button, you'll get prompted with a warning saying if you cancel, those changes aren't going to take effect and you'll lose them. So maybe you typed something wrong and you're not sure what you did, and you just kind of want to panic and go back. You can just hit cancel and leave, and then come back to it. So then after you hit OK and acknowledge, you're back to the general window. And the cool thing about the script is that it's just like any other tool, so you can get information to be displayed in the result table. In this case, you can specify which variable you want to show. In this case, they have distance and script enabled. And also in the fail, so if tool fails, you can have a string to be displayed. If you want it to say, who knows what, I guess, even if you already want to, you say the script failed because of this or that. You can enter that in there. So if you looked at the cause, it'll actually have some information in there for you. And that's about it for just kind of the general overview there. And when you're writing code, what you and I type and work on is this Intellect source code. That's the readable type. Once you press the compile button, it jumps from here over there, and it gets compiled into Intellect machine code that we can't read and doesn't really mean much to a user. And then and that's what gets executed by the camera. But every time you open up that script editor, you see this code. And so if you make a change to it and don't compile, those changes never made it into machine code. So your script will be running, but it'll be running on an older version. So it's something to be aware of. It becomes a force of habit. You just kind of always hit the compile button before you get done editing or exit the editor. Some things that you should always do is add comments. So you can document some settings or kind of describe what's actually occurring in the code. You can comment out a single line of code using 2 forward slashes. And when a line is commented, by default it turns a green color. So you can quickly look at some script and see which lines are activated or not. And then if you want a chunk of code or a chunk of comments to be commented out, you can you start with a /* and then you an asterisk / at the end. I use comments quite a bit to describe and what's happening, but I also use it to, if I want to test some ideas on how to write a piece of code or construct maybe a string or some kind of calculation, and I'm close with one version and I don't want to delete it or modify it. I'll just copy that line, comment out the original, and then I can start tweaking the duplicated one. So if I make it better, great, I can delete the original, or if I make it worse, I can always go back to what I had. I use it more of an editing tool than actually creating notes. So here's an example of using the 2 forward slash, this is a single line. And when you do the /*, the whole thing becomes green. Even this last little curly Q becomes commented out. Only until you put the end of the comment command, where it won't comment out the whole darn thing. Some of the reserved words, they turn different colors: blue, green, purple, orange. I think brown is actually a color of some reserved words. And so if you're typing and you see a word change colors, not black, then you know this is a reserved word. And if you have a variable name that's unique color, then it's probably a good sign that you probably can't use that as a variable name. So double, you create a variable of type double or a sensor object, those things will change colors. And you'll see that when I go into the editor. To declare variables, you can create your own variables, create your own names, make them as descriptive or cryptic as you please. Usually make them pretty descriptive but easy to type, because you usually got to use that variable throughout the whole script. So if it's a lot of upper and lowercase letters and numbers, it can get kind of difficult to type over and over again. It's just more prone to fingering a key or a spelling error, then your code won't work. You can either use numbers or strings. You can have a Boolean variable type. If you do create a string, it has no mathematical properties, so it's a string of characters. You can't give a string of 1, 2, 3. It's a string. You can't add or subtract anything to that. And Then the numbers can be a whole or real number. It can be a whole number, any integers, or you can go into doubles or a float where you can actually have decimal places. And anytime you're doing mathematics, you probably want to use a real dial type so you can get the full information. And a lot of tools, a lot of the sensors that are used, return values that have decimal places. So most of your variables are doubles, and if you have counters, perhaps make those integers. So to declare a variable, you first type the data type. So on the very top one, you just type a string with a capital S. It changed orange. And then you type space, then your variable name, so anything you want. Then you can set that equal to a variable at this time, or you can do it on a separate line if you like. Same thing for double and integer. You type the word in, changes color automatically, and then the variable name, and then the value. And you can actually, at the end of this one here, for instance, I could put a comma here, and another variable, and another value. Keep going all in one line if I wanted to. There's no really advantage to it in processing speed or performance. It does the same thing, just maybe some style that a programmer or you have. So let's see. Okay, so I'm going to go and to start it, you click on a button, and you I already covered some of these things where you can press the compile button, or you can go up to script and then compile. And the magnifying glass is that's to find or to look for a certain command or a word. The one cool thing about scripts is that you can save them as a text document, a .txt file if you like, and or actually it says as a .esr file, which I think opens in Notepad. And you can go File and Save or Save As, and you can just save it, and you can modify that in Notepad or WordPad if you like, but you're not going to get any of the nice color coding or indexes. And one cool feature that was added a couple versions ago is that you can protect your scripts. So if you have a lot of intellectual property in there, your customer has their own special things that they do that they want to keep secret from competitors, or you, the distributor, have a lot of work in there that you don't want another distributor to walk in and take. You can hide the script, so where once it gets compiled and hidden, the script only exists in the machine code, doesn't exist in the source code, so you can't see it any longer. And information on doing that is in the help files. You type in protection or passwords. It's there. A couple of different steps to enable it, but once it's enabled, it's pretty good. One caution I have is that if you do use it, you usually want to keep an unprotected version for your own personal use. We can at least see and edit it in the future. And on when you put the camera in runtime environment, then you can protect it and hide it. That way, the camera on the line is working great, but someone won't be able to go in there and manipulate it. And then here, if you wanted to have outputs in the result table, you would check the check boxes, and then here's an example. It's showing d equals, that would be the distance variable, and then the s equals, so that's the string variable. And all of these have different data types. A distance is a double. Intensity, I believe, is an integer. So if you have an angle, I think is a double or a float. So depending on which values you want to equal to those, you may or may lose some resolution. I can demonstrate that. So in this example, I'm just going to solve that problem that I discussed a little bit earlier. Let me go to the sharing slide. Let me know if anybody can't see my sharing slide. You should see Intellect user interface and a couple circles. Okay. So what I've done here is I've drawn two circle fit tools. So I'm finding a circle on the left and a circle on the right. And then I have the crosshairs are the circle fit tools find the center of the circle. And then I have a math tool calculating the distance between centers. That gives me all the pieces I need to write a script and find the result. We'll delete that old script. So I'm going to create a new script. So I'll go to the toolbox. It's down near the bottom here under scripts, and I'll click on the tool. So there I have my tool, my new window here. So I'm going to give it a name. I'll call it my script. And let's see. Apply, and then I'm not going to do anything in outputs quite yet. I'll just hit the edit button. So now I have the script editor dialog window here. So the first thing I want to do is I want to, I can add some description here. Something like that, great. And so the first thing I want to do is declare a variable. So I'm going to declare it with data type double. So double, and then I'll call it edge to edge. So I'll go E to E. And then I can put a semicolon there. Press the compile button. And then down here at the bottom, it'll say no errors. That's great. So if I want, I can set that equal to 0 if I want. Probably a good idea, just so it declared a variable and gave it a value. So if I use it later in the script, it'll have actually a value assigned to it. So then, I want to do that calculation. I can say E to E equals. So the first thing I want to do is find the distance between centers. So I can click on this tools here on the right where these parameters are. And the C2C, or center to center underscore distance, is my name of my tool. And then here's all the information that's available. Available I'm interested in this one case is distance. So if I double click distance, it gets added over here on the left. Now I just took the data from that tool, added it to this string, or this equation here. So I want to take that, and then I want to subtract out the two radiuses of the two circles. So I can say circle 1, and then a variable is called radius. I can add that. So I'm going to add the two radiuses together. Go circle 2, do that radius, and then throw a semicolon at the end of it. So now I have edge to edge equals center to center distance minus the sum of the radiuses. If I want to see what that looks like, I can go to the my script parameters. I want to display this as distance. I can double click distance. I get myscript.distance. You can type these out. You don't have to. You go to the parameter section if you know the syntax of it. But a lot of times it's easier just to pull it out of the parameters. So I'll say myscript.distance equals. I can just type in E to E and compile again, and still no errors. So that's all it took to find that distance. 3 lines. I'll hit OK, apply. In the result table, I still don't have any information. I need to go to the output section and enable the distance to be displayed. Now if I look down the result table, saying 88.959. Fantastic. So that's all it really took. And I can go back in here anytime. I can make some manipulations and edit information. And then I probably should add some comments in here, but it's not too difficult. If I really wanted to get fancy, I could have done this in a single line. So let me do something like here, and then I'm going to do, I'll just take my distance, And I don't even need to even declare that variable. I can just take all of this information like that. I'm going to comment out this code I did initially. I can comment out all of this actually. So let me show you that command here. So let's do a /**. Everything's just turned green, including these two semicolons, and I want to end it right there. So I'll do *//. Now my code here is still enabled. I can compile that, hit OK, and apply, and I get the exact same number down there. So the better way would probably be to do this, but it may not be very descriptive to a user or to an operator or somebody who has to go in behind you and figure out what's going on. Doing it the initial way, the first way, was a little bit more labor intensive, but it's a little more flexible. So now I have this E2E variable. So if I need to multiply that, or I need to find the slope of that line, perhaps, or the angle of it. If I did that here, my distance, I couldn't do any of those things. So there's advantages, to a lot of different approaches and techniques, and you just got to find the one that solves the application, the one that you're most comfortable with. Is there any questions so far?
Where did the C2C come from?
Okay, good question. C2C_dist is a center name that I created. I acknowledge this, and it's actually a math tool that I call C2C_dist, which this math tool, it just found the distance from circle 1 to circle 2.
Okay.
So that's something I did ahead, a little bit of homework I did ahead of time.
Okay, I missed that part.
Okay, yeah, no problem. So that gives me the raw distance, and then I found the distance. But if you really want to be critical, it's assuming that the script that I calculated is assuming that these are perfect circles. If these were ellipses, the tool is going to fit a circle. A circle is not going to fit an ellipse. So for some reason, if there was some chunk of something over here, causing this to not be a perfect circle, my mathematics and my theory would be incorrect. It wouldn't actually be finding the distance. It wouldn't actually be finding this space here. So if I were to have this application, I probably wouldn't even do this. I would do it a little different. I would use a script. You'd have to, but it'd be a lot more complex. It would. I'd be finding the location of these two centers, maybe having a tool relocating to maybe to a feature find or feature count to see if I can measure this distance across here. So if there is any kind of anomalies or any kind of junk hanging off the part, I could find it. This is just a little simple script, but we are making assumptions that these are perfectly round and we're finding the exact center. So just be aware of that, I guess. All right, let me go back to the PowerPoint real quick. Okay, so that was, I had this information displayed down there. Some ways to debug, and I'm going to go back in that script and create some errors after this little section here. But some programming errors and some syntax. A lot of times it's typos. If you have a FI instead of IF, I'm a pretty poor typer, so I have a lot of spelling errors usually. And forget the semicolon at the end of the line. That's a real common problem. We have a lot of experienced users out there, and they may call support for help, and they get embarrassed sometimes because sometimes they forget the most simplest thing, and it's a small little semicolon at the very end of the script, and it throws it off. And I'll do those errors and show you what kind of information you get from that. At runtime, when you're actually running the inspection, you may get an error. The script may fail, and it'll say something like fail line reference line 5, and so it tells you which line it choked on. And if the script fails at a line like that, it immediately stops. It doesn't proceed to the rest of the script. It'll hit line 5 in this case and choke and then jump out and then fail. So you may get a variable if it's not initialized. So for instance, they created a variable called pi, but they never gave it a value. And on the next line, they just multiplied something by pi. Well, because pi has no value, it can't execute this line. So the error is up here, but the line error that's going to show you the problem is right here. It's saying a variable is undefined. And then there's also logical errors. It's not doing what you want it to do. That can just be bad programming, bad techniques, or as simple as you have the greater or less than symbol backwards, or the wrong words. You have pass or fail there. So there's a lot of errors, and it's probably one of the most difficult things to kind of troubleshoot. But there's a lot of information available for you, and a lot of example code that you can cut and paste from to get you most of the way there. Some ways to prevent common errors is that you always compile, and usually I'll compile pretty frequently just to keep tabs of myself, make sure I'm not getting ahead of myself. You make all calculations readable. So instead of using cryptic variable numbers or names, you can describe them. If it's a really complex one, you can make a comment above it or below it or on that same line saying the edge, in our case, edge to edge equals the distance from the center points minus the radius 1 and radius 2. You could just spell it out like a sentence and make it very descriptive. That way someone could come up and see that next line of code and say, okay, I don't know what these variables mean or what they are, but I know what it's supposed to be doing. So you can try to help them a little bit to figure out what's going on. Don't use shortcuts. Don't use shortcuts. That's what I did. I did that whole code in a single line. So that's it's difficult. There's only one line, so you think it may be easier to troubleshoot, but because you're doing a lot of things in a single command or a single line, it may be easier to spread things out. And typically what I do, if I have a very complex calculation, maybe I'm using trigonometry or algebra, I'll spread it all out. I'll take all the multiplications or whatever I need to do in pieces and slowly build up the final formula. And once that works, I'm happy with it. But I can go back and start getting rid of some of those variables and combining it down into a single line. So at the end, maybe it's a nice line of code, but when I started off, I had it broken up in a couple of different places, and I had some debug commands to figure out what the variable is at a certain location, so I can take it piece by piece instead of all at once. And use parentheses. You can calculate over several lines, like I was mentioning. Comments are always important, especially when you need to send it to tech support. Send it to us so we can take a look at it. We can get up to speed a lot faster on what you're trying to achieve if there are comments there. And I'll be honest, I usually don't do any comments until I'm done with the code. Or I may make some little notes here and there for myself, but when I'm happy with how it's running, then I'll go back before I send it off to a customer. I'll go in and couple lines at the beginning describe what's going on, define what some key lines are doing, maybe define what this condition or this loop is doing and what it's waiting for. Just to, I don't really do it at design time. I do it more at implementation time, I guess. Yeah, you can also print out the values. You can in the result table, the script debug window. I do that a lot. In the script debug window to see if I have a lot of conditions or loops, I'll put a little debug statement there telling you which loop it's in. So when it's running, I can know which loop it's going in and which one it hasn't reached yet, or maybe one of my conditions is never going to be true, so it never gets into the meat of the program that I really want it to. So I use debug prints are pretty valuable. And speaking of debug prints and what you can do, you can create strings. And here's an example of creating a string to be displayed in the result table. With the same technique, be implemented for the debug print statement. For instance, instead of just simply having the value d equals 3.14, if you want to be more descriptive, you can set a string up saying pi equals 3.14, and the max number of some widgets, I guess, equals 10. And to do that, you would create a quote. So basically, once the string is always inside of quotes, you can close the quote, then you can concatenate or append, add a variable name. And if you have another string afterwards, you put another plus symbol, another set of quotes, type some more gibberish, close it, and then if you have another variable, you can plus symbol, max number in this case, then semicolon. So if you start playing with debug prints and strings, you get pretty familiar with how to create and add and figure out how to construct a string. I think, yeah. So here's an example of the debug print command. I'll get in and show this right now. So for debug print, you just type in the word debug print, all one word, capital D, capital P. And if you have it syntax right, it'll turn purple. That's the first thing I've checked, is if it's not working, make sure it's purple. Then you open parentheses, and everything inside the parentheses is what the print statement is going to be spitting out. In this case, it says start with a string pi equals, and then you add that variable. Then the next statement is saying another line, max number, and that variable. And every time the script runs, you're going to see, every time it hits this command, it's going to spit out that debug print to a separate window. This is an example of that window down here. And the information on that window, the first thing is, this is the time the camera has been up and running. Basically, this is how many milliseconds the camera has been on since power up. As soon as you plug it in, the firmware boots up, this clock starts running. Not that critical. I don't think I've ever needed to use that or look at that. The second column is the script tool number. So if you have multiple scripts spitting out data, that's a good way to figure out which one is passing which number. And then also you have the third column is dictating the foreground or background script. If it's a foreground, it'll be a 0. The background script, it'll be a 1. When you use the debug print window in a foreground script, you'll see the data update twice. And it's a pretty big confusion point for users. What's actually occurring is the camera is doing what's called a reinspection. So the first time you see the data is from the initial inspection. The trigger was sent, script ran, it spit out the debug print data. The second time you see the data is the camera does a reinspection to generate the image marking and then all the data to send to the user interface. So if you have Intellect connected, you have this window open, you're going to see it pop up twice. Because the first time the camera does whatever it can to get the results out as fast as possible to a PLC or a robot or whatever. And the second priority is to give us the information, give the user the information. So it happens that if it detects that there's a UI connected to it, they'll do a reinspection and ship that data out. It's not really a big deal unless you're using a counter. So if you're using counter, you just incremented a variable twice, or incremented or decremented a number, or you redid a calculation. So if you use counters, I recommend using registers, and I'll talk about those a little bit in the future here. So really don't spend too much time and worry about why you're seeing it twice. But if you do have a counter for some reason, then it kind of becomes a little bit critical. Okay, so I'm going to direct to my UI and start creating some bugs to show you what some of the error conditions are. I'll go back into my script editor. So if I forget a semicolon, I'll remove that one there. And hit the compile button. I get an error down here saying error 15, syntax error. general syntax error. So if I double click on that, it shows me, it highlights the location where the error is. And the semicolon error is tricky in the fact that it doesn't show you the exact line the error is on. It just shows you, or it does show you where the error occurs, but it's not where you actually have to make the edit. So it happens that there's no semicolon here, so it goes down to the rest of the program trying to find the next one. And what happens, it hits the end of the program and okay, it failed. So if I'll put a colon back in there, but I'll remove the very top one. So yeah. So now it's saying error 8, and that 8 corresponds with the line number. If I double click on it, it highlights line 8. Now it's saying this is the error, and you may pull your hair out sometimes trying to figure out why in the world your math is incorrect, when the whole time is that you just forgot a semicolon up at the very top with the line preceding it. Usually if I get syntax errors, then I'll usually you can figure out what's occurring there. So I'll write a debug print statement here to show you what that's about. So print, so it turned purple, and then open parentheses, quote, double quote. This is some info, just whatever I want. Then usually what I'll do, I'll put a colon there, space, and then a quote, just for formatting, just so it looks a little bit nicer on screen. And then I'm going to put the plus symbol, and I'm going to put my variable name there, E2E. Then I can just do a close parentheses and a semicolon. And I'm good. If I compiled it, no errors. If I forget the plus symbol and compile, I get a syntax error. These errors aren't too descriptive, but if I forget a quote, it's gonna actually, if I forget a quote, it's saying it's trying to, it's a corrupt string, it's trying to do a literal, and it happens that I never close it, so it thinks that the rest of this is a string. So it's a combination of errors that there's no semicolon at the end, there's no close of the string, there's no closing parentheses, so it's kind of compounded there. Some of the other errors, if I create a new variable, this error is pretty common. It's pretty common in Intellect framework. We didn't really care too much about it, but Intellect it became a lot more sensitive. So if I'll create a variable of an integer, int. I'll call it ABC. I'll set that equal to 10 numbers. I can compile that. It works fine. Well, integers only are 2 bytes, so you can't do a very large number. If you do, it'll say integer literal out of range. So it'll tell you if you're stuffing a number in that's too big for the location. So now I have this integer ABC. So if I do this here, I'll copy and paste it, and I'll comment out that line. And I'll use the variable ABC up here. And I'm setting an integer equal to all this math. Oh, I typed it wrong. So I typed it correct there, ABC, but my variable I created here was ACB. So here's what my syntax is. So the error now is saying cannot automatically convert type double to int. Use explicit type conversion. This is an error that pops up a lot for new users of Intellect. What it's trying to do is that this number is the double, or it's, it has decimal places. It has a very large number, and it can't fit into this integer. The integer doesn't support decimal places. So it's warning you that we can't do it because you're going to lose information, you're going to lose data. And if you're okay with that, and you want to lose the data, what you can do is what you call casting. You have to cast the output as a suitable data type. And in this case, I would do open parentheses, int, close parentheses, and I'm going to put the whole thing inside of another set of parentheses. Now what I'm doing is that everything that happens inside of here, I'm going to cast that as an integer and pass it to a variable. And now it's okay. So actually, let me uncomment that out, and I'm going to show in the myscript let's see, I'll do myscript.string. String equals, and I'll do, I'll call it double. And I'll use ETE, and I'll create another little text. I'll call this one int, and use ABC. So now I just created basically a string to show in the results table. So here, I'll put down my string. So the first double is the value is 88.959 and keeps on going. It runs out of room, it's so large. The second one shows integer is just 88. So I lost all those decimal places. And maybe in a lot of applications you want to display that number, but you don't want all those decimal places. This is one way that you can do that. So what you could do is you could cast this value as an integer to get rid of all the number, but you can also, for instance, if you needed to still use it in the script with all the information, you don't want to lose it. One way you could do that is instead of doing it here, doing this math twice, having two variables with almost the same number in there. I'll comment this line out. I can go back to the string. I could cast the variable here even. I could go E2E, type in an integer there, and do it, and I should get the same multiplications. So I get int 88. Or double 88 integer, that's the variable I declared earlier, or the value I declared earlier. So if I do it this way, I'm not corrupting any of the data here, but I'm displaying it without all the decimal places. I'm displaying it as an integer down here. So for a user, they may not need to have all the information, but you want to keep it around to do other calculations, you can definitely do it. There's two ways, and there are two different reasons to get kind of the same result. See, how can I create a visualize variable? All right, I can do that. I'll create a variable ABC, and I'll create a variable called Nick, and then I'll set that equal to 0. So I'm going to create an error. I'm going to create another error by typing Nick equals ABC times 2. Compiles fine. There's no problem with that. It's great. If I apply that, now I get an error here. It's saying the script fails, and the cause is saying uninitialized variable line 12. So now I have to go into my script, find line 12, and that's where it's erroring out right there, which is peculiar. Oh, okay. It actually errored out there because I'm using it, but I never gave it a value. So actually this line of code down here, it never even got to there because it choked up here before that. So that's the error I wanted to show, but it showed it a different place than I wanted. But those are a lot of the common errors you're going to get if you don't assign a value to ABC. If I even set that equal to 0, it'll all work now. It should apply. Yeah, there's no error any longer. Also show. Okay, I guess let me show the debug print window. I haven't using it here. So I'm going to display some information in the debug print window. So in order to do that, you go to View, Script Debug Window, or you can press Control S. So then you're presented with this window. You can start and stop it, clear it. Every time you run an inspection, again, we get two pieces of data. We get, the time in milliseconds, tool number, foreground, background, and then the string I want there. And you see it twice, and again, it's twice because of that re-inspection. Every time I click the button, we get two new ones. Actually here, there's a good error here. So this one, on this image, it failed. It's saying distance is no valid output. The reason why this tool failed is because this circle couldn't find anything. It was actually minimum contrast. So this caused that distance tool to fail. Because that distance tool failed, my script failed. Now it's saying line 9 is the error. If I go to line 9, it doesn't really give you much information, but I know because those two tools failed, it can't do the distance because there's no value. It's just like originally when I took away this value here, ABC equals 0, if I remove it and just make it ABC, it doesn't have any information. It's dead. That's one way. That's one common error that you see. If, for instance, in this case it wouldn't work, but if you wanted to access this data, even though the tool failed, you can do that. And to do that, there's a little cryptic code that's kind of hard to find in the manual, but it's called fail on failing reference. F-A-I-L. Fail on failing reference. And you set that equal to false with a capital F. I believe, or is it lowercase? Lowercase f and semicolon. That means that the script isn't going to fail if one of its references fail. In this case, my script's still not going to work because distance is equal to nothing. It's not going to work. But if I wanted to monitor whether or not the tool passer failed, then it would enable me to do that. That's another cool little trick there to get data from a tool and make the script continue to run if something fails. Sometimes you may want the script to do the ultimate. It's right there. Now it changed from line 9 to line 14. Line 14 is right here, and it's because E2E doesn't really exist because I wasn't able to calculate it. Actually, no, it's because of that. That old trick again. So now it should work. Now it works, but it gives me a value of negative 120. What that number is, I don't know where that number came from, but that my script is now passing even though the information it's using is failing. So you have to use that with some care. You don't want to automatically do it every time because right now my script's passing, but it's using junk data. I think that's only all the little gotchas I can think of right now. Real quick, we'll cover transferring data. Touched on it a little bit earlier to take data from tool and pass it to the background script or pass it to another product. The way to do that is via registers. And in Intellect, you don't have to use script to get the value into a register any longer. You can use tags. But I'll show you how to do it in script if you like. So let's see what else we got. Yeah, for instance, here you're showing that all these 3 scripts in our product can access the same register space. The description here is there's a limited number of registers. There's 16,000 DVT registers, and I think there's 64 modbus registers, if I recall. There are 8,000 modbus registers. Okay, so registers 16 to 8,000 are available for use modbus, and then you have registers 32 to 16,000 for DVT registers. You don't really want to ever use the register 0, anything under 31 really, because 31 on the DVT side of things, because those are reserved for the system. The system takes values such as are inspections running, output status, system status, if the system's busy or not, and turns those bits high or low automatically behind the scenes. So if you go in and meddle with that, you can definitely change the settings inside the camera. The modulus type of registers are commonly used to transfer data from the camera to something external, so maybe to a robot or HMI, PLC, or even to another camera. You have data going from a DVT camera to an Insight camera, or vice versa. And in Intellect, these are now separate. In Framework, they shared the same space, but Intellect is a lot better. And how much space do these things take up? So different data types take up different chunks of registers. Integer can take up to 2 bits. So the value you can store in there is 2 bytes. A double, on the other hand, can take up to 8 bytes if the number's big enough. And a string takes up a register per character. So every character plus the end character takes up a space. So if you're saving, if you're writing a register of type string, but you should be sure that you're not storing off a paragraph, because the paragraph's going to take up quite a few registers, and it may run over some of the other registers you have fed. For instance, if you write a double to registers 100 to 103, then write a double from 102 to 109, the data 100 and 101 will be unintelligible, because the second write is you overwrote and trampled on the initial one. The best rule of thumb is to skip 10 between registers. You have 16,000 of them, and the likelihood of running out is pretty slim. Usually I start at register 100, for instance. I'll use 100, then 110, 120, all the way up. That means any data type other than string, you'll be all set. If you are using string, there's a function called string.length that determines how many characters are in the string. Then you have an idea of which registers are being written to. So I'll do a quick little thing about showing how to write registers, and then I think we're almost done. Then I'll show you some other cool little things you can do here. So I'll go back to that same script I created, edit. So now, who knows what I got in there? I got a lot of junk code in there. I'll get rid of this. So what I can do is register. I can type it out, or I can just go down to the functions over here, say registers.
You're not sharing.
Oh, I'm sorry. Thank you.
You're welcome.
Hey, there you go. Thanks, Greg. So I can either type registers, type the word register write or register read here, but I'm going to, I can just double click on it here. So I'm going to register write double, and then the first thing is the register name or number, which location you want to, basically which box or which hole you want to put it in. So I'll just type in 100, and then the value or the variable name. So I can type in a number, or I can actually enter in the variable. In this case, I'll do the E2E. So semicolon at the end, compile it, no errors. So if I want, I can apply that, trigger inspection, and to make sure it's there, there's several ways I can do it. I could have debug printed and did a read and got that data back we did earlier, or I can go into the communication section and look at the registers there. I can go to registers, and I'll type in 100 over here. I'll type in 99. So register 100 to 104 is what's actually being, well, that data, that variable, that value, is taking up these 4 registers here. And it doesn't look like much. You can't really make anything heads or tails out of it, but that's what's there. If I really wanted to see what's in it, I can do a tag. And the tag is a new technique to get data in registers rather than writing a script. So it makes it easier to get simple values in and out there. Real quick on tags, I don't want to get too crazy with it. I'll type register 100, I'll say it's a double, and then it's now under the value, but showing me the actual value. That's one way to also make sure it actually received it in there. But that's the topic for another day. And also, to read it back, you do sudo register read. I can go here. I can do register read double. And to do that, you just type in which registry you want to read from. I can do registry 100. And let's see what I'll do is I'll take off. Okay, I can do that. I can do, I'll do myscript.distance equals register read double 100. I could have created another variable if I wanted to, but I won't. So there it is, 88.959. When you're using registers, be aware that registers only get written to when inspections are running. So whenever you have this button highlighted, and I guess another thing is make sure this icon in the upper right is moving. Then it'll get updated. If it's not running, the reads will still work, but the writes won't. So again, if you have a counter of some sort and it's not incrementing, then that's a good tip-off to say, hey, there's no inspections. The inspections aren't running currently. Is there anything else you'd like to see, or if you have time? I can show you some examples and scripts and stuff that I worked on in the past, and show you what's capable of it.
That'd be good.
Okay. So here's a quick little product that I created that finds the distance between the centers of objects, and it marks a line here. So it marks a cyan, or it's magenta, I guess it is. There's a magenta line between the shortest distance and a cyan line between the longest distance. And then in the result table it says the min distance between objects is 201 pixels, max distance is 300 pixels. It's a single tool doing a blob. You could easily make this an object locate or a pattern find. So if I open up that script, a little bit more crazy than the past. But this is a customer who kind of needed it, and I helped him get in the right direction. And after he was happy, then I kind of continued on and overdeveloped it pretty much. This script can actually function the transform plane. So if you did an image calibration, you change the units to feet or microns, the units will change also, and the tools. So instead of just showing you the number of pixels, it'll actually display it in the actual unit. To do that, you have to use this transform ID and use a lot of stuff here. Here near the very top, I declare my variables, declare my transforms. So the first thing I do is that if there's enough objects found, calculate the distance between them. So if the number of objects found is greater than 1, then I can actually do the script. If it's less than 1, it just jumps over all this stuff and spits out in the result table not enough objects. It goes through, and I have this pretty interesting loop where it'll find the first object as an anchor, then loop through the other objects. And then after it loops through all of them, determining if it's closer or further away, it'll increment to the next point, to the next as an anchor object, and then loop through the remaining. Keep going and going and going until it reaches the very end. And here you can see some of my debug prints that I have for anchor loop, floating loop, minimum set, maximum set. So while it's running through, I can look in the debug window and see where along, where is it and what's it doing? How is it processing the data? And usually after I'm done with the code and happy with it, I'll comment all the debug prints out, just so they're not taking up space. So if the user has other things going on, it's not just obfuscating his data. So here's actually conversion to actually do the transform ID to determine which value it is, and if it's a certain value, you just get units. I type in the word meters and all that good stuff. Here's some information how to mark the image. At the very end is when I spit out the information. But this script is pretty not too crazy to do, very simple. But once you start doing transform ID and the transform planes, it started getting a little interesting. What else do I got? Here's a script that I created that the R&D guys made sure that wasn't needed any longer in the future. Let's see if I can find something interesting. There we go. So what this script does is that it finds all these green dots here, the edge points, and calculates the distance from those edges to the center of the circle that it's found. And it marks the maximum and the minimum distance between those edge points. It wasn't too difficult to code. Here's the script. A couple lines, not too complex, but it's pretty effective, and now it's part of the Intellect tools in 1.4. You look at the circle fit tool, there's actually a min-max radius, and that does exactly the same thing as I'm doing, and it marks the lines just like I'm marking them. But if you have Framework or an older version of Intellect and you want this functionality, here it is. So it draws a magenta line for the shortest and a cyan line for the longest. Let's see. One cool thing is that you can actually draw things on the screen. For instance, I'm drawing the date and time on the image. So if I increment it, I get that information. I also get the image number, so I can increment that. And I also have added the functionality of having a tool down here. So if the tool name, so if it's tool 1, it passes. It's there. Let's see. I should be able to change the name. Let's see. See if I can break my script. Yeah, I broke my script. All right. Wasn't sure if I coded that in yet or not. So if the tool passes, it marks it in green. If it fails, it marks it in red. Let's see. Let's move the line down here. Trigger it. Just caught that. So now the tool marking is in red there. And this script is a little bit more, quite a bit more complex. I created a function called marker, and then you don't need to edit anything in here. And then here's actually a map of all the characters to actually draw on them. A bunch of special characters down here, and you can go in and edit them, but I was just not. And down here is where you really want to start editing, if I can say that. So what you do is create a string. In this case, I use the image ID, and I pass some variables into the marker function. The X and Y is the upper left corner of the string where I want it to. The font color, what color I want it to be printed. If I want a drop shadow or not, I can do that. And also how much spacing I want between characters and the size. So it was purple up there originally, and it was kind of hard to see. I'm going to make it black, and for reference, up here is the numbers equal color. So I'll make it 12, and I'll make it really big. I'll make it 15 pixels high. The larger you make it, the slower it takes to process. So that's why I made it very small. Because what happens is that this marking is actually part of the image. So if you save the image off, they're basically timestamped now, right on the image. So if you load up an image in emulator, that marking is part of it, and you can actually see exactly when it failed or what inspection number it failed. And then the shadow color, I'll add a color to it. I'll add yellow, whatever. I'll compile it, hit OK, apply, and now my image string is now larger. So you can take that code and add anything you want to it. All you do is pass variables into that marker project. Had some time, and I created a Pac-Man and a ghost character. So now you can have Pac-Man chasing the ghost across the screen. And it's not anything really different other than it's that same chunk of code in the beginning, the text, and then I basically toggle between two characters to kind of animate it a little bit. But yeah, you can, if you want, you can change the sizes and colors, and all it is just you do some determination, you pass these variables into the marker function, and the marker function does all the work for you. But this is a function that Intellect has nailed pretty well. Intellect, this is pretty painful to do. So, and the last thing I wanted to show you was we get a lot of requests for set params. And set params is a way you can manipulate the shape and settings of tools at runtime. So you can automatically or dynamically change where a tool and how a tool is drawn, or you can change the threshold values while the camera is actually on, running and without any user intervention. This is an example here using just 4 points. I use 4 datums to specify the boundaries of a blob tool. So if I trigger it, my blob tool is now that crazy shape. Using set params is pretty dangerous. If you have the order of execution incorrect, it'll crash the camera pretty hard. The order of execution is you want the script to run before you actually draw the shape. If you have it out of order and it doesn't crash, the image you see and what you're marking is going to be doing is really going to be synchronized, and it'll be really difficult to troubleshoot that. So to do this isn't very difficult. The hardest thing is just kind of figure out what code to do, what code to type in. So I create a couple strings, a couple variables, sensor and a product object. So what I do is I ask which product is the current product. I get the specific tool I want to change. In this case, it's called tool 5. And all these parameters here are dictating where it's drawn, threshold, what type of tool it is it area-based or line-based? Is it circle? In this case, it's a polygon. So these, you should manipulate these in this case. And if you want to do other things, to figure out and decipher what these things actually mean and what they represent, go to the website and search for Intellect command list. I think it's 1.x, the file name. That's the last one we have. It goes into pretty good detail of how to change and manipulate shapes and parameters out of tools. And if you need any help, get as far as you can and give us a call, and we can hopefully help you the rest of the way. So in order to do this, the set params, which is down here, I need to pass it the param string, I called it, which is all this junk in the front. So I have to tell it how many edges or how many corners I want, and then I tell it the locations of those corners. So I have three basically values or variables I'm kind of crunching all together. So for param edges here, I take the location X and Y of tool 1, X and Y of tool 2, 3, 4, and then back to tool 1 to close off that shape. So I basically went clockwise. Basically started at tool 1, went around it, and right back to tool 1. So it's a simple four-corner tool. But so here it's only changing when I move these datum points around. But there's nothing stopping me from finding the center points of these circles and making the center points being my bounding area. So every time these shapes move, I'm looking at the center, looking in the middle of all that region. I can have hundreds of edge points. I don't need to have 4. I can have hundreds of them. Or, you know, I think the maximum one I've done was around 115 edge points on a polyline. So if I had a very complex shape that I wanted to look at the interior of, I could find those edge points, access all of them, and then the set params command. So I have a very complex shape following an edge or a contour. That's kind of a little, you know, thing to make you guys aware of what's available, and there's a lot more things that can be accomplished in the scripting language. I get a lot of system files and product files from customers, and I was looking through them a while back, and I would say maybe 10% of them have scripts in them. I thought scripting was used a lot more than it really is. I was kind of shocked that that's all I had. So it's a good tool to use. Usually it's the last thing you have to use. You have to kind of do some complex math or have a real drawn out way to determine if a part is good or bad. So if there's any questions, you know, shoot them at me. If you want some of these example scripts, let me know. I can email them out. The marking image, the marking script where it was marking the text and the Pac-Man, that's available on the website. If you search for alphanumeric, that's available on a download for the zip file and maybe a README file also. Is there anything that I didn't cover that you guys want to see or hear?
That was looking good, Nick. Just those set params and those things are kind of nice to know where those scripts are held. Like you say, they're on the website.
Only the alphanumeric one is. I don't think the other ones are. I just pulled those out of one of my folders I had here.
Okay.
I have them on my desk. I have them on my folder, but I don't think they're on the website. We're still trying to find a good place to put them. On the Insight side of things, we have the snippets section. Kind of like to have something like that for the DVT side of things.
Yeah, that would be great.
But I guess they'd have to be use at your own risk. So you don't really. Scripting is the hardest thing to apply for support because it can be as complex or creative as the programmer desires.
Yeah, well, that's my main question is if we have a library of some sample scripts to do, and that sounds pretty good to have at least the image marking on there.
Yeah, the image marking one's there. There are some other ones, I think. Yeah, there are some ones there, but I don't think they're in any specific location. It's just a matter of if you know the keyword to search for.
Well, that'll give us something to work on then.
Yeah.
Thanks, Nick.
Yep. Anybody else?
Is there a schedule for the in-depth scripting?
We'll probably be doing those at the advanced training classes.
Okay.
I think the first one is beginning of April or May in Minneapolis. I'm not sure what the course curriculum is yet for those classes, so don't quote me, but I'm pretty sure we're going to be doing a scripting class at them. Miguel Perez, the training manager, would know more about the curriculum, and the DSM for sure would, or the RDSM would for sure know when and where and what he wants to be taught.
That's correct. There will be advanced scripting content in the advanced class, and you can find those online under advanced training. And the first one is scheduled for May 1st in Minneapolis, like Nick said.
Okay, yeah, I just haven't seen it on there.
Yeah, and usually in those advanced classes, we'll kind of gloss over everything I just did today and go into different data types and conditional loops. Maybe do some fancy stuff like use background scripts and do some image objects or open up socket connections, all kinds of interesting things. Okay. Well, if there's anything else, give us a call here at Tech Support, and we can help you through any of the applications you guys have. We always like getting your sample scripts in there so we can take a look at them and figure out what's going on with them. Okay. Well, if there's nothing else, have a good weekend, guys, and let us know if we can make any improvements.
Hey, you too, Nick. Had a great time. Thanks.
Thanks, Nick.
Bye.
Thanks.